In this interview, we're going to meet Tom Eriksson. Tom Eriksson is an interaction designer and researcher, and he works for IBM in their social computing group at the Watson Lab in New York. And Tom has been working for IBM since '97, and before that he spent 9 years at Apple. So he's the ideal person to tell us about social computing. So Tom, what kind of projects are you and your colleagues doing at your social computing group at IBM?
Sure. There are a couple of areas we're working in. One part of my group is working in what we call the next billion space. IBM is interested in where the next billion users are going to come from, and the obvious answer to that is from the developing world. I don't really like the term developing world very much, but I think at least people understand that. So part of my group is trying to understand and develop applications that run on low-end mobile phones that will provide value to people in other parts of the world besides, the sort of industrialized West. So that's one area that we're working in. A second area that's primarily my focus is IBM has an initiative called Smarter Planet, where I like to say that we're putting the word smarter in front of everything we can think of. So we've got Smarter Planet, and then within that we've got what we call Smarter Cities, which is what I'm working on. I've been interested in urban design for actually a couple of decades, so I really leapt at the opportunity to get involved in the urban area. And mostly when IBM talks about making things smarter, what it means is put a lot of sensors out, gather information over networks, run analytics on the network and figure out how to optimize things, or maybe figure out how to create a dashboard that will give managers a way to understand what's going on, and coordinate things, which seems fine. However, my mission in IBM is to make sure that smarter is not just about sensors and digital technology. What I'm concerned about is that our notion of smarter also includes people, right? I don't want to see IBM end up designing smart boxes for passive people. Instead, anyone, but certainly people who live in cities, have deep knowledge about where they live, where they socialize, the paths they travel over. They care about those areas because they live there, because their family and friends are there. They identify with them. And all of these things, I think, give people in cities an enormous amount of both knowledge and motivation that they can contribute to making cities both more efficient, but especially more humane and livable places. So one example of that is, this is not primarily my project, but I've been working with Lauren Tervine's group at the University of Minnesota, and they have a system called Psychopath. And what Psychopath is it's a system designed for bicyclists. And the basic issue is, how do you help bicyclists find bicycle-friendly routes around the city, right? If you go to something like Google Maps, which actually has introduced a feature recently for bicyclists, but back when we started they hadn't. If you go to Google Maps and request a route from point A to point B, it'll take you along an interstate. No guarantee it'll be a good path for a bicycle. And so what Psychopath is about is, first of all, it's open source. Secondly, it's focused on a particular geographic area. The first case was the 7 metro county area of the Twin Cities. And what it does is it combines data from multiple sources. So it has terrain data from the US Geological Survey. It has a layer of street map data from the Minnesota Department of Transportation. It has a map of bicycle paths from another source, and it combines them all together, okay? And it enables you to do routing over that. Now there's a problem, which is, since those data are from separate sources, they're not integrated, right? So if you see a bike path crossing a street, you don't know if there's an intersection or if there's an overpass. And so what Psychopath relies on is it relies on its users to add data to the map. And in fact, the Psychopath map, unlike the Google map is, you look at it on the screen and it's pixels. The map in Psychopath is objects down to individual blocks. And so anyone can go in, it's a wiki, and edit the geometry of the map if they want. You can go in and you can remove a street or put in a new street. And although that might not seem very useful, in fact, if there's a dirt path that goes from here to there that allows bicyclists to have a little shortcut, that gets put into the Psychopath map. And you can do other things. You can tag routes. So you can say this particular path is unpaved. You can also rate things according to how easy or difficult they are to bicycle. And then when it comes time to request a route, you say, I want a route from this point to that point. And the points are things people may have entered, so you have your local names. I can request a route from Lucia's to the U, right, which isn't in any map database, but people in my area of the city know what it is. And you can say, and I want it to be very bicycle friendly, as opposed to the shortest possible route. And you can say, I want it to have lots of hills, and if possible, dirt paths, because maybe I'm a mountain biker and I want some good exercise. Or you can say just the opposite. Try to avoid hills. Try to avoid things that are unpaved. Favor bicycle paths. And it will compute a route using the data that everyone has entered. Okay? And I'll just add that when Psychopath first came out with, when Google first came out with its cycling route finding, at least Psychopath at that time did computed the same route that was better and a kilometer shorter than Google gave you. And I attribute that to the user entered information. And in fact, we did an interesting experiment. When Psychopath was first released, there was no user edited data. And so what we did is we took the routes that were requested the first 2 weeks, and then 9 months later, after 400 users had entered thousands of edits, we recomputed those very same routes that were requested at the beginning, and they were a kilometer shorter on the average. Probably better, but we can't measure that, but they were better. And so that's a nice example of creating something for a community of people that the community has a motivation to contribute to, that provides them real value. And as it is used, it not only provides value, but it becomes something that they identify with. So cyclists in the Twin Cities are proud of Psychopath, and it's now become, in a small way, right, a symbol of the vibrancy of the cycling community. So that's one example.
So talking about value, why is it valuable for IBM to have people like you and your colleagues working on social computing?
Well, a couple of things. So within IBM, IBM is a company of nearly 400,000 people. We have a tremendous amount of expertise inside of IBM. And so one issue is how do you tap that, right? It's very hard to manage 400,000 people, right? And to know who knows what and to bring the right people together. And so to the extent that IBM can leverage social computing for itself or for its other customers, IBM, has lots of very large customers, social computing can make a lot of sense working within the enterprise. Let me give one example. A number of years ago, we had an experimental in-house system called IBM Community Tools, where people could join a community, and community was a bad name for it. It was really more like just saying, I'm interested in Java programming, or I'm an IBMer who lives in the New York area, or I'm a fan of collecting glass. It could be anything. And what happened is you would join these communities, or channels, I think is a more accurate way of putting it. And anyone on a channel could send a little message to everybody else. And so I'd be sitting here working away on my computer, and there would be a bing, and a little window would slide out from the corner, and it would have typically a question on it. Basically, people use this for asking questions. And so if I'm in the Linux community, there might be a bing, a question would come out, and somebody would say, I'm trying to install WebSphere on Red Hat Linux 2.3, and I'm getting this error message, help. And if I can help, or even if I can't help but I'm curious about the answer, there's a button I can click on, and it pulls me into a group chat with everyone else who, at the very same moment, saw the message and responded. And so what you would get is people would send out questions. Often these would be consultants who were at a client site having some problem, and in a moment they send out a question. They get a group of people from all over the world sometimes who not only, well, first of all, the question might not give enough information, so they say, well, what install package did you use, or what's the number on the obscure error message you're getting, and so you could, they'd find out more about it, and then they could very often solve the problem right then and there, tapping, in some sense, IBM's worldwide expertise. And whenever a consultant did that, nobody again ever asked, well, why did you hire IBM? Because it was such a striking demonstration of the power of being able to tap a large community of expertise.
But I guess, doesn't it also interrupt a lot of people to say, help?
Yes, so that's one thing. We did a study of this system. This is not one our group designed, but it's one we studied, because I initially heard of it and I thought, what a stupid idea. This is going to drive people nuts. And it did drive some people nuts, and so they left the system or never joined it. But a bunch of people, for whatever reason, it didn't drive them nuts. And actually, when we did this study and looked at people who were using it, although there was a lot of traffic over the system, there were 900 public communities, and most people were only members of a few. And so the average person would maybe get 3, 4, 5, 6 little bings a day. And at least the people who stayed on kind of liked it, right? And people would say, oh, I'll see a question there, I don't know how to answer it, I'll pop in and learn the answer. Or I'll pop in to see who knows the answer, right? Often knowing who knows an answer is more valuable than the answer itself. So that's the kind of thing that happened there. And yes, it was annoying for some people, and so they didn't use it, but enough found it bearable, or that it was fine.
So what first got you into social computing?
Well, it was a gradual process. I think for me, one of the starting points was when I first came to IBM. On the second day I was there, they asked me to make up something that I might like to work on. There was no guarantee that I could work on it, but that's what they told me. And I had just had an experience I found kind of interesting, which is a few weeks ago, but before that I'd been in a Kai workshop. And at the end of the workshop, we all said, well, this is really interesting. We should keep talking. Let's get a mailing list going. And so we discussed that, and we realized, there's actually an old mailing list that's dead now that we could just sort of re-inhabit. So we agreed that we do that. This is a workshop on patterns. And so I was supposed to send out the first message. And so I went home, and then I thought, well, when exactly should I send out the message? Because people need to subscribe to this. But mostly people weren't saying anything. They'd subscribe, but and the system wouldn't tell me who was there. And so I thought to myself, wouldn't it be nice if somehow, as people signed onto the mailing list, I could get some kind of cues as to how many people were there, and I kind of thought to myself, well, I'd just like to see something very minimal, like little dots showing up, and so kind of when you get a big enough crowd, then you get started. And so that was the very, maybe not the very beginning of the thinking, but that was a very formative event, because I started talking about that to the folks I was working with at IBM, and somebody else in our group, a software hacker, a small talk guy, went home and over the weekend built a little system. It wasn't quite what I envisioned. It wasn't a mailing list. It was more of a online chat system. But eventually that evolved into a system that we came to call Babel, which had, in addition to being a sort of ordinary multi-room chat system, it showed when people logged on by putting little dots inside a circle. And not only could you see how many people were logged on, but whenever people were active on Babel, which means they type a bit or they move the mouse, their dot would sort of move into the center of the circle, so that if you have a bunch of people who are actively, typing, which you do when you talk, or if they were just mousing and scrolling as you do when you're reading messages, you end up with this tight little cluster of dots in the center of the circle, which gives you a feeling of, you walk along the street and you see a crowd of people all gathered together, and you're curious and you kind of want to know what's going on over there, right? And that's how Babel worked. You could actually close down all of Babel except for this tiny little visualization that we called the cookie, and be doing your work, and you glance up, maybe you finish an email or something, you glance up and you see there's a cluster of dots, and it was, my friends are there, they're talking about something. And so
I want to listen, or I want to participate.
Yeah, so it pulled you right in. And so for me, that was one of the big ahas sort of on the social computing journey, that these social effects you have in the real world, seeing a crowd, being curious, wanting to join because you're curious, could be used to design online systems too.
Thank you so much, Tom, for sharing some of your knowledge and perspectives on social computing. And if you want to know more about social computing, you should read the chapter Tom has written at interactiondesign.org. Thank you so much for watching.